Alright, so I wanted to show you how to graph the 6 trig functions. So I've made a really crude drawing here of the unit circle. I haven't filled in all the points, as you can tell, but these are the only things that you'll really need to know to get a pretty good idea of what their graphs are going to look like. So I'm going to be using this to help me as I go through this. So I've started to make myself a little table here. So what we want to do first is we're gonna sketch the graph of sine of x, and we're going to do that by recalling that sine is represented by these little y values as we look around the circle. So the y values represent the value of sine for each individual angle. So for example, the sine of pi over 2 would be 1, because the y value at that point is 1. I'm going to go through here and label these really quickly. I'm just getting these numbers from the unit circle. So for example, at 0 pi, the y value is 0. At pi over 2, the y value, as we just saw, was 1. At pi, we're back to 0 again. And then at 3 pi over 2, we're at negative 1. And 2 pi, we're back to 0. So I want to graph these points real quick. Notice they all fall between negative 1 and positive 1. So we mark off pi over 2 units, pi units, 3 pi over 2, and 2 pi. And then I want to plot my points and sketch this graph in. So I've got a point at 0 pi, comma 0, at pi over 2, comma 1, pi 0, 3 pi over 2, comma negative 1, and 2 pi 0. So what I get is this nice little curve here. Turns out it actually keeps going in both directions. Because think about how we got these points. All we were doing was rotating around our unit circle. So we started here at 0 pi, pi over 2, pi, 3 pi over 2, 2 pi. We're back at the same point we started. So if I go over again another pi over 2 units, that cycle is going to start to repeat. So it turns out the sine graph actually does something like this, and it will go on forever, making the same pattern. So graphs that do that, we call them periodic. Graphs that repeat, we call them periodic. So one period of pi is one section of the graph that repeats over and over again. So when we refer to the period, we're talking about a distance. So you may be asked for what is the period, for example, of sine of x. The period would be the distance it takes to repeat. So if you look at this graph, the time it takes to get back to 0 and be increasing would be 2 pi units. So one full period for just the parent function of sine is 2 pi. Another buzzword you might hear with trig is amplitude. The amplitude measures the distance from the max to the min, and they take half of that number. So it's half of the max minus the min. So notice if we're going between 1 and negative 1, that's a distance of 2. Half that would be just 1. So the amplitude for sine is just 1 unit. Alright, so that's sine. Notice since this goes on forever and ever in both directions, the domain would be infinite, from negative infinity to positive infinity. Notice the range is going to be between negative 1 and positive 1. And really, that's all there is to sine. So again, we're just using the unit circle, looking at the y values of those points that correspond to these angles as they go around the unit circle, and then plotting those points. Notice I didn't graph all the points that we know from the unit circle. I skipped over pi over 4, and pi over 6, and pi over 3. The more points you plot, the better your curve will look. And this gives us a pretty good idea of what's going on right here. So let's also take a look at cosine. So I'm going to use the same little table here. So remember, cosine we saw is represented by the x values. So where sine was the y values around the unit circle, cosine is the x values. So for example, if I'm looking at 0 pi here, the x value there is 1. So I put down that the cosine of 0 pi would be 1. the cosine of pi over 2, well, the x value there is 0, and then negative 1, and 0, and positive 1. So just like the sine graph, the numbers start to repeat after you go a full 2 pi units around. You get back to where you started again. So we start graphing this between 1 and negative 1. Got pi over 2, and pi, and 3 pi over 2, and 2 pi. So at 0, cosine is 1, and it goes back to 0. At pi, it's negative 1, and back to 0. And at 2 pi, it's back to positive 1. So you'll notice that this graph looks very familiar. It looks exactly like sine did. The only difference is that it's shifted over pi over 2 units. So sine started here, whereas if I were to go in the other direction, in the negative direction, to negative pi over 2, we'd have this graph here. And this part here looks just like sine did. It's just starting at a different location. So that's really the only difference between sine and cosine, is that cosine has been shifted over 90 degrees, or pi over 2 units, to the left. So just like sine, it has the same period, because it's the exact same graph, just shifted. So it's still 2 pi, and the amplitude would still be 1 unit. That's really all there is to graphing cosine. So while I've got cosine graphed here, let's take a look at the reciprocal of cosine. Of course, you would know I'd be referring to secant. So if we wanted to graph secant, well, we know it's the reciprocal of cosine. We're taking those values of cosine and we're flipping them upside down. So for example, if cosine had a value at, let's say, let's do one that's not actually here. We know that the cosine of pi over 4, at pi over 4, cosine would be the square root of 2 over 2. So secant would be 2 over the square root of 2, which would reduce down to just the square root of 2. So we just flip those numbers upside down to get the reciprocal. So what happens is we can actually flip all these y values upside down also. So for example, where cosine is 0, we usually write that as 0 over 1 will work. If I flip that upside down, I'm going to get 1 over 0, which, as you know, you've been told over and over again, you can't divide by 0. So where cosine is equal to 0 on our graph, we're actually going to have an asymptote. It's like a line that you cannot cross. It's like Gandalf is saying, "Thou shalt not pass," and you shall not. You shall not pass the asymptote. So we won't have any points defined on our graph at these asymptotes, but that's okay because secant doesn't seem to mind. So that we just flipped the points at 0. What happens if we flip 1? Well, as it turns out, 1 is the same thing as 1 over 1. You flip that upside down and absolutely nothing happens. It's still 1 over 1. Let me just give myself some room to write here. So as I just said, if we flip this point, nothing happens. We still have a point at 1, 1. Or sorry, at 0, 1. And over here at 2 pi 1. Same thing with negative 1. If I flip negative 1 upside down, well, nothing happens. So still got all these points at 1 and negative 1. But what about this point here? Let's say hypothetically, I don't know exactly where that is, but let's say it's maybe at, I don't know, 1/10, or the y value is at 1/10. If I flip 1 over 10 upside down, what do I get? Well, I get 10 over 1, which is way up here off my graph. So what happens is when you start flipping these fractions is they get really, really big. So your graph is actually going to get really, really large, and it's going to approach your asymptote. So when it flips, you can kind of visualize this part flipping up, like that. Same thing happens down here. This part flips down, and if I had continued, you'd see another full hump here, and it would flip up as well. So it flips, and those values start to approach these invisible lines, these asymptotes. So if you were to look at this on the calculator, you would not see the cosine graph here. We just use that to help us graph secant. If you graph secant on your calculator, all you'll see is a whole bunch of little, they look kind of like parabolas. They're not actually parabolas, but if that helps you visualize it, go with it. They're more like this kind of U-shapes. Parabolas, we know, go off in both directions forever and ever. These are not going to go past the asymptotes, but they kind of look like U's. So kind of visualize it that way. But that's secant. I guess while I had sine, I should have showed you cosecant, but it's found the exact same way. And as we talked about, cosine is just the sine graph shifted over pi over 2 units. So if I move these values here, these U shapes, if I move everything on this graph over to the right pi over 2 units, well, I'll have my cosecant graph. So I'm not going to show you that one. I feel confident that you can look at what we just did for cosine, and you can probably figure out how to take the sine graph and draw in your asymptotes and start flipping things on your own. So see if you can take the time and graph the cosecant. Should look something like this. Feel free to check yourself. Be sure you know what these values are that we have asymptotes at. So see if you can do that, and while you're working on that, you can pause it, try to graph it yourself, and I'll start preparing for the next graph. So if you want to try that, pause it right now. Otherwise, we'll continue and try to graph tangent. I got about 4 minutes left to sketch a graph of tangent. That's probably not going to be enough time, but we'll try. So tangent, we looked at it before. We said it was the same thing as sine over cosine. We just said that sine was the y values around the unit circle. We said cosine was x values. So it makes sense that tangent, if it's sine over cosine, then it's also y over x. So for example, if I wanted to find the tangent at 0 pi, I'd look at my unit circle, I'd find the y value, it's 0, and the x value is 1. So at 0 pi, the tangent would be 0 over 1, which is 0. At pi over 2, we see that the y value is 1, and the x value is 0. 1 over 0 is undefined. It turns out that pi, it's back to 0, and then undefined, and then back to 0, and then undefined, and then back to 0, and then undefined. And this goes on forever and ever and ever. So real quickly here, I'll start sketching in this graph. 3 pi over 2 and 2 pi. So at all the pi over 2's, we have undefineds. So we have asymptotes there, lines that we cannot cross. And all the pi's, well, we're equal to 0. Same thing holds for 0 pi there. So this doesn't really look like much of a graph to me, so I've left some room inside my little chart over here. I'm going to go in and show you what happens at pi over 4, and at 3 pi over 4, and at 5 pi over 4, and at 7 pi over 4. So if you look at the unit circle, both sine and cosine at all those values have the same value. The only difference is that as you rotate around the circle, some of the values will become negative. So as it turns out, pi over 4, the tangent would be 1, and then negative 1, and then 1, and then negative 1. So just like with the 0 undefined, that pattern repeats with 1's and negative 1's. So at pi over 4, we saw it was positive 1. And at 3 pi over 4, it was negative 1. And positive 1, and negative 1. So I'm making myself some little tick marks in here to represent pi over 4. So what happens is tangent does something like this, and looks kind of unlike the other ones, but I guess they all look kind of unique if you think about it. So you get this kind of a, kind of looks like an x to the third graph, a cubic, except again it's restricted. There are asymptotes on either side, so it'll never go past those, so it's not actually cubic, it just looks kind of like it. But that's tangent, and just like we just showed for cosine, to find cotangent, that'd be the reciprocal, you're just going to flip those values. So everywhere that tangent was 0, cotangent has an asymptote. I'm trying to do this quickly. Everywhere that tangent has an asymptote, cotangent's going to have a 0. And when we flip 1 and negative 1, absolutely nothing happens. So those points stay the same. And cotangent looks just like tangent, only mirrored, I guess you could say. And the asymptotes, instead of being at pi over 2, for cotangent they are at 0 and pi and 2 pi. So, also one last thing to notice in the last 15 seconds, the period for both these graphs is only pi units. It only takes pi units to rotate, whereas all the other 6, it was 2 pi for the period. So hopefully that was quick and informative, and there you go.